Okay, clear or not? I hope all the students may you don't know about integration in a mathematics. This is a one type of application. Okay, of all the different things are combined together by in a mathematics by the things that is only called integration. Yes, yes, combine the things of a different things. Meanwhile, the thing. Okay, clear or not? That is only called integration. Here, the work done by that different forces are there. In the last class, we already discussed it. W is equal to somewhat different forces are there, like F1 and F2, F3, S last finally dash 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 plus Fn is equal to into S. We written like this. Okay, clear or not? Individually, there are different forces are there. This is only another format we have to write in a different ways. That is the somewhat A to B. There is a work is done. W A to B is written as integration of A to B. Yes, F bar dot ds bar. Got it or not? Integration means what? We are taken the what the different small things are there here. Yes, combined by the mathematical application, it is called integration. This is the small divisions are there. The small divisions are from A to B is like that it will be there. We have to write there is in this particular form. Okay, now by application of mathematics. Okay, now it is only called integration. This is also like that application. We are taken A to B integration F bar dot ds. You know very well A to B. It is also written as dot product. When we remove the dot product, it is written as what? A cos theta. FDS cos theta. It is written as FDS cos theta. Okay, clear or not? Yes, here it is also written as FDS cos theta. It is also written as yes, one of the equation as about here F A to B integration of A to B fx. Before that, you have to write there is a F bar is one vector. F bar is one of the vector fx plus xyj plus zk, and another one is also there here. That is the ds bar. The ds bar is equal to dxi plus dyj plus dzk. Okay, like that we written it is. Okay, got it? And now there is a W A to B. It is equal to taken as A to B. Yes, fx. When we written it is the dot product of these two things, you know very well. The dot product of two vectors is also written as fxi plus fyj plus fzk. Yes, dot dxi plus dyj plus dzk. How we written, you know very well. Fx into dx, fx dot dx plus fy dot dy, fz dot dz. Got it or? Yes? I hope you got it here. Already we discussed in a vectors. Okay, clear or not? Vector multiplication. We have the two types of products. One is the cross products, another one is the dot products. In that one already we are discussed it is. Okay, got it or not? I hope you got it here. Now that the same thing, whatever the thing here we written, that is written as here. Yes, fx dot dx and as well as fy dot dy, f dot dz. Okay, that is only we have to write here fx dot dx plus a to b fy dot dy a to b fz dot dz. Got it or not? This is only we have to write here work. Okay, now yes, for a discontinuity of any particular thing. Okay, yes, please write down it is whatever the work done by the variable force. It is based on x axis, it is based on y axis, it is based on a z axis. Yeah, next one is it is about what actually when there is a variable force is there. Now there is a we are take spring forces. Whatever the spring it is taken. In the spring there is a forces are in a different position. We are considered. We are applied a force in a one direction. It is opposed by the another direction. We are applied the force. It will be extended. But when we remove again, it will be compressed. Got it or not? It is a compressor. It will make opposite direction to the force application. The displacement will make the opposite to the force direction. Okay. Based on that one, directly the spring, whatever the working the spring, it is a contain a work done in a different mode compared to the remaining or the general situations. Okay, how it is once we have to check it. Okay, here there is a, we take our particularly one blank. Here it is attached with one black here, one black here, that is about x is equal to 0. Okay, clear or not? And we are taking here. Next here, one more thing is also we consider, that is about it will be changes its position because of extension. It is a changes its position. Somewhat distance is traveled by it will be taken as yes x1. It will be taken by x1. It is x is equal to 0 to the x is equal to x1 distance is traveled. Okay, clear or not? At that time, what is the work done here? That will be calculated by one formula. That is again be written as here 0 to the x1 f into dx. F into dx we are considering. Got it or not? F into dx. F is equal to s directly proportional to yes, it is written as minus k into x. Okay, clear or not, all the students? F is equal to taken as what here? Yes, F is equal to taken as minus kx into dx. The k into x, k is the one of the force constant. X is the taken as what here? X is the displacement, which is against the working of this particular force. Already we are discussed initially only. When we applied a force on the spring, opposite to the force, there is a displacement may available. That is only written as minus kx into dx. Okay, from the integration we get it is okay. In the place of f dx, we have to write minus kx into dx. 0 to the x1, it is equal to also written as minus kx into dx. Yes, we written like that minus ax squared. Yes, by 2 it is 0 to the x1 we written. Okay, we written as the work done is equal to W is equal to yes, we written minus k into x square by 2. Already we discussed it that integration of x dx x to the power of n into dx. The formula is there for us x to the power of n plus 1 by n plus 1. This is only formula. Based on a formula, we written it is here x to the power of 1. We are consider 1 plus 1 by 2. Okay, clear or not? Yes. What we have to write here? 1 means what it here? X to the power of 1 plus 1 by 1 plus 1. Got it or not? Understood or not? It is x to the power of 2 by 2. Okay. This is only we have to write. Please move on. What is the heading? Work done in a spring. Spring forces. Sorry. There is about the string we are already considered. There is the two things we have considered at the time of a compression and as well as the rarefactions. Okay, in the tabular format of our textbook they given at the time of the compression how it will be going on, at the time of the rarefaction how it will be going on. During the problems also again we are get that the things we are discussed based on the problems when we apply the force, how it is a compressed and how it is a reflected. Okay, there are the things again we'll get. Now there is a two forces are there. One is a we are consider it is a conservative force and as well as a non-conservative force. Okay, the two types of forces are there. Okay, which one is called a conservative force? Which one is called a non-conservative forces? Okay, conservative force. Which is totally depending on the path of the forces only. It is not depending on the yes. Meanwhile, whatever happened here, there is only the whatever path followed by the body. Yes, the work done is totally depending on the path of the body. That type of the forces are called the conservative forces only. Okay, clear or not? Suppose the point A and the point B is there. Okay, now it is a different paths they are considered here for the reaching from A to the B. Okay, the work done is totally depending on the initial path and as well as the initial point and as well as the final point. It is not depending on any other situations, whatever happened between A and B. Okay, that type of the forces are called what? Conservative forces. Examples for the conservative forces are yes, all the non-contact forces. Once check it, gravitational force and as well as the magnetic force and as well as we are consider it is what? Yes, electrostatic forces, elastic forces. These all are conservative forces only. The conservative forces are nothing but what? It will be works against the work done against the force moving a body depending on only the initial and final position of the body and not nature path followed by between the initial and final position. The work done by against the conservative force in a moving body over any path between a fixed initial and a final position will be the same. Okay, clear or not? Here whatever work done, here whatever work done, that is depending on these two work done points only. Okay, clear or not? That is not depending on any path followed by it. Whatever path may followed by it, the work done is become same. Okay, that will called as that is called as a what? That is called as okay, na conservative force. Attraction forces, repulsion forces of magnetism, and as well as the gravitational force is the work between the okay, na any two planets or any celestial bodies are become what? A conservative forces only. Got it or not? In a particular closed path, okay, na, the work done difference between the initial path and final path is become zero. Okay, how much the work done is here? The same work done is here also. Okay, suppose you take here whatever the gravitational force is there between a sun and as well as the earth. In case it may not say what happened along its a path. Suppose it is elliptical path, na? Yes, sun is here and earth is revolving around the sun in an elliptical path. Okay, here the force is may not a conservative. It will be defense. What happened? It sometimes attracted towards the sun, sometimes go away from the sun. It is occur actually. No. Every time the same force acting on the sun, whatever the path followed by it. Okay, clear or not? It is near by the sun or away from the sun. Okay, got it or not? In case like that, there is a year is the same, not same. Okay, now whatever same years are formed, okay, for same duration, it may not occurs. Okay, in case it is not a conservative nature. Got it or not? Yeah, like that, atom is also not become stable. Okay, why? Because in atom there is a electrostatic attraction forces and repulsion forces are there between the same charges and opposite charges respectively. Okay, attraction is occur between opposite charges. Repulsion is occur between a similar charges inside of the atom, whatever path followed by it. Why? Because there is a dumbbell shape is there, double dumbbell shape is there inside of atom. But whatever the path followed by the electrons inside the atom, but it is a constant. The work done is become constant. Okay, clear or not? It is depending on initial position and final position only. Meanwhile, whatever the path followed by it, it is not a as considerable. That type of the forces are called conservative forces. As which is not followed, it is called what? Non-conservative forces. Okay, now it is depending on the path. It is depending on not on the initial and final position. Meanwhile, every point is accountable. That is called non-conservative forces. Got it or not? About this concept, we are going to discuss tomorrow. As clearly as about the based on the problematic part and as well as the energy component also. Thank you, students.